Properties of exponents. Whenever we are multiplying like bases, we take the exponents and we add them. Whenever we have some base raised to a power, that term is raised to a power, we take the exponents and multiply them. Whenever we have a product raised to some power, both factors there are raised to the power. Whenever we are dividing like bases, we subtract the exponents. And whenever we have a quotient, both the numerator is raised to that power and the denominator. Okay, let's look at these examples. Here we have y squared times y to the fifth. Since they have the same base of y, we add those exponents, and 2 plus 5 is 7. Here we have z cubed raised to the power of 4. So we are going to multiply 3 times 4 to get z raised to the power of 12. Here we have a product, j times k. This is one term squared. So both the j is squared and the k is squared. Here we have that like base of x in both the numerator and denominator. So x to the 10th divided by x cubed, we subtract, and 10 minus 3 gives us 7. And then here we have the quotient m divided by n raised to the power of 4. So that's m to the 4th divided by n to the 4th. A few extra properties I want to talk about. Whenever we have x raised to some negative power, we take that, put it in the denominator, and it becomes a positive power. And then anything raised to the power of 0 equals 1. Those are all of the important properties of exponents. Okay, so let's practice. So looking at number 1, let's start with 8 and 4 here. 8 divided by 4 gives us 2. And now let's look at each like base. So we have x squared divided by x to the 5th. 2 minus 5 gives us a negative 3. Looking at our y's, we have y to the 4th divided by y to the 1st. 4 minus 1 gives us 3. And then we have z to the power of 0 divided by z cubed. 0 minus 3 is negative 3. And now we take those negative exponents, and we take the term to the denominator and make that exponent positive. Another way you could have approached this problem, here we have x squared and x to the 5th. We have more x's in our denominator. We have more x's by 3, so we'll end up with 3 x's in our denominator. All right, looking at number 2, I recommend pausing the video and trying this one on your own. So looking at 6 and 9, 6 divided by 9 gives us 2/3, because we can simplify that. All right. Looking at our x's, 7 minus 0 gives us 7. All right. Y squared divided by y to the negative 3. So that's going to be 2 minus negative 3, which gives us a positive 5. And then looking at our z's, that'll be negative 4 minus 5 to give us a negative 9. And we could put z to the negative 9 up here, and then we know that since it's a negative exponent, we need to bring that down to the denominator and make the exponent positive. Okay, let's look at two more. So here, we're multiplying. And whenever we multiply, that means we're going to be adding those exponents. Remember, dividing, we subtract the exponents. Multiplying, we add. Okay, so we're multiplying 3 times 4 to give us 12. And now let's look at the exponents of the like bases. X to the 4th times x to the negative 5th. So 4 plus negative 5 gives us a negative 1. And then y squared times y to the 0. Remember, anything raised to the power of 0 is just 1, so that's just that y squared. Or you can think 2 plus 0 is 2. Okay, we can't end an answer with a negative exponent, so we're going to leave the positive exponents up top in our numerator, and then the x to the power of positive 1 is in our denominator. All right, last problem. Negative 5 times negative 2 is a positive 10. X to the 5th times x squared. 5 plus 2 is 7. Y times y cubed. So remember, that's y to the 1st. 1 plus 3 is 4. And then lastly, we have z. Negative 3 plus 0 gives us that negative 3. But we cannot end with that negative exponent. So we take that term to the denominator and make the negative 3 a positive 3.